Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust. This is a live stream where myself, Luciano, and
Roberto,
and sometimes also Eugen, that unfortunately today couldn't join us. We are software engineers trying to learn the Rust programming language, and we are doing that by trying to solve Advent of Code challenges every week, Monday, more or less around 5 p.m. GMT. Today we are a little bit early, but almost all the time we are at 5 p.m. GMT. You can check our schedule on Twitch, and this way you can be up to date with the next time we are going live. If you don't know anything about Advent of Code, it's basically a coding challenge that is published every year around the Christmas time. That's why it's called Advent of Code. And it's basically 24 exercises every year where essentially you have to solve specific problems by using code. We have been doing this for a while now. We have a repository that you can see here. And in this repository, you can find all the exercises that we solved so far. You can also check out some of the previous episodes on YouTube, and the link to that is available in our channel description. So feel free to check out all our previous material, and we will continue today from exercise number 15, I believe, right?
Yeah, I think so.
Okay, so let's get started.
But you know, I'm terrible with numbers.
Yeah, I think it's 15. Yes, it is. Okay, so I'm not gonna kill you by reading all this stuff. I'm gonna try to summarize the exercise of today. And basically, the way I understood this exercise is that we have a sequence of numbers. For instance, here we have 0, 3, 6, so 3 different numbers. And this is gonna essentially build a series of numbers based on some rules. And the rules are described here, which basically means that you look at the last number of the sequence and say, if this number has been already seen in that sequence, then the next number is going to be 0. Sorry, if this was the first time that that number was spoken, means if 6 has never been in this sequence, then the next number is going to be 0. Otherwise, if 6 was already in the sequence, then we will need to remember let's say the turn. So this is like a memory game where every time somebody's giving you a new number, it's a new turn. So you will need to remember the last time that number was used, what was the turn number. And basically the new number is going to be the difference between the current turn number and the turn where that number was already seen for the last time. So let's probably see some examples because probably it's going to be more clear. So for instance, here we have a sequence of initial numbers, 0, 3, and 6. So, and we need to continue generating the following numbers from turn number 4. So we look at the last number, which is 6, and basically we see that that number was never mentioned before. So the next number is going to be 0. Now, turn number 5, we look at the last number, which is going to be 0, and this time we see that 0 was already mentioned previously, and it was mentioned in the turn number 1. Also note that turns are 1-based and not 0-based, which is probably something we'll need to keep into account. So basically here is saying that since 0 was seen in turn number 1, and currently we are in turn number 5, as you can see here, the next number is going to be the difference between 4 and 1. I thought
0 is in turn 4 and turn 1.
Right. Okay.
Now we are generating turn 5.
Mm-hmm. So we need to look at the previous one. So 4 minus 1, which 1 was the last occurrence of 0, and 3 is going to be the new number in the sequence.
Yeah. Then you put 3 into the next array.
Exactly. So at this point we have something like 0, 3, 6, and then 0 again, and then we are putting 3 again.
3. And then
now the next term, we look at the last number. The last number is 3, and we need to see when it was the last time that we saw 3, because we know it was in the sequence. So, and it was second turn. So again, we do 5 minus 2, and we get 3 again, right?
Yeah.
So at this point, we have something like this.
And another 3, yeah.
And we keep going. And this game can be played endlessly. Now, of course, we need to have a stop condition, and the stop condition is going to be, I think, here, that says, can you play this game, this simulation, until the turn number 2020? And at that point, that the result is going to be the result of the exercise. And here we are getting some example. So for instance, if we start with this input in the turn 2020, this is going to be the final value, and so on. There are different examples. And you can see that even if you change slightly the sequence, you can get very different numbers. So our input is going to be this one. So this sequence with 6 numbers. And of course, we need to simulate this until turn 2020, and we expect to find this value. Make sense, Roberto? Do you want to add anything?
No, yeah, it's fine. We could also add, normally we just have one test with the input and the output. We could add some other test, because in the end, 1, 3, 2, 2, 1, 3 are just strings, and we can...
Yeah, it would be very easy to add new tests, for sure.
To add new tests, just to double check the output numbers.
Yeah, let's keep that for the end, but it should be fairly easy to do it.
Okay, yeah.
Okay, so
we need a data structure to remember the last position of a number. So an hash map.
Yeah, for sure. So I suppose a hash map will be good, because what we want to do is associate a number that we are seeing with the turn that we saw that number. So if we see that number again, we can easily check when it was the last time we saw it. And
update the number, because at that point, the last time that we saw the number is now.
So I'm going to import an hash map, because we definitely need to do, let's call it occurrence. And this is going to be an hash map of, I want to use usides, because I expect that we are going to have to do loops and keep the iteration reference. So probably with usides, we don't need to do conversions. So let's do that for now, and we'll see if it makes sense. Okay. So initially, this is going to be new and empty. Now, of course, we need to pass the input. We didn't do that. Maybe we should do that as well.
At this point, we parse it as a usize too, even if they are
numbers. Yes. So let's say, let's start vals, I guess. And this can be a vec of usize as well.
We need the value and the position. So we will call enumerate on this vector later.
We can... right.
Also, enumerate is starting by 0, from 0, from 1, from 0 probably.
Enumerate starts from 0.
Okay, we have to remember to plus 1.
I'm thinking that rather than doing something like map, actually, we don't even need to do enumerate here.
We can do it later on the vector, okay.
So I suppose that in our input, we are seeing that there is no repeated number. I don't remember if that was a hard rule. We can probably make the assumption that there is no duplicate in the starting sequence, right?
And
because I think even in the examples here, there was no duplication.
Okay, so let's go with this rule.
So what we can do here, the simple approach that I was thinking about is that literally we just do map, and then we say every x will become x dot parse, and then we just collect. And I think this should give us the sequence of start values. So let's do that very quickly just to be sure that it's working. And if we run the first test, what did I do? Start vals, of course. Now run it again.
He's not happy about that collect.
He's not happy about collect. Let's see why. Cannot be built from iterator. That's interesting.
The map, we are applying parse to all the...
Oh yes, I forgot to unwrap, because of course this can fail. We know that the input is same, so this will be all numbers, but of course nothing is stopping us from having something like this, right?
Yeah.
So we need to unwrap. Now I think this should work.
Now
okay.
Complaining about we don't use variables, but okay.
Yeah, just warnings. So we have 2, 1, 10, and this will be properly parsed as a vector of usides.
Okay.
Right, so now the next step is we have a sequence of starting values. We have an empty hash map with occurrences. What we can do is we can populate the hash map with the starting values.
And
probably we'll need to exclude the last number, because that will be like...
Yeah, the last number of the input sequence is our first input to the sequence, I mean. So that
because
with our input is the 6. So basically we don't have to put the 6 in the hash map, because the 6 is the value that we use to start. So we can loop over start vals except the last value.
Yes, so let's do that. So if we do, let's see, for what we want to do, we're probably going to have the position. So let's say turn and n, I guess, in start vals. And we can do, I think we could do -1. I don't know if that will work.
No idea. And now we have to enumerate this.
And we need to iter, I guess, and enumerate.
And then enumerate, okay. I always forgot iter.
Okay, it doesn't like this one, so what we can do is start vals.len, not leak, -1.
Okay. Do we need a let somewhere, or?
I don't think so. So now what we want to do is just to say occurrence.insert, and then key value pair is going to be n. So we want to use n as the key, and the third as the value.
So we can look up for n when we have the number in our hands. And
see exactly
what was the last term. Also, this is 0-based.
So do we want to do +1, right?
Or we do +1 here, or we remember to do -1 later. So
I think let's keep +1 here, because it feels more intuitive if we need to debug. Okay. Because we can print the sequence and
values. Yeah. Okay.
So this should populate the hash map, and I think we can just print it now just to visualize it again. And we should have something like occurrence. And we expect to see, let's see. Okay, we shouldn't see 6 because we skipped it and it's not there, but 0 is there and it's number 5. 1, 2, 3, 4, 5, that's correct. 1 is there, is number 2, 1 and 2. So this seems to make sense.
Yeah.
Right, okay, so now we need to start our simulation until turn 2020, right?
Yes, our first value is the last value of a start vals. So the value.
So do we call it next, I guess?
Yeah, let's call it next.
Because in a loop it's going to be always the next value. For now, it's the starting point. And this is going to be start vals.last.unwrap because we know it's not empty.
Okay.
And now we do the for loop. So we do for turn.
This is a reference to a usize. Okay, let's think about this, the references later. So now we have to loop 20 times less the turn that already passed the tar.
So we start from this, right? And we go up to 20 included, I suppose.
Yes, because we move it.
Because we're using one base.
Yeah, we do +1, so I think so. But well, off by one error, worst case, we try with and without, and we see when it works. Very empirical.
Okay, I like this empirical approach.
Yeah, try.
Okay, so now we have the number of turn, and next we can start to codify the two rules that we have. So we basically need to see
if we never saw the number before. So
which basically means if occurrence contains key next.
Can't we do something like if some occurrence of next? No.
If right.
If
so
let last position, if let
yeah, we can use that entry. I think there is something called entry which gives you a reference that you can use, and I don't know if you can destructure an entry.
But there was not if let some variable equal to occurrence square brackets. No, I'm dreaming.
You're right, because I don't know, we can use get. Okay, I think this will work. Okay. Because this is giving us an option. So we can do if let some turn, right? Some turn.
Last scene.
Last scene, yes, I like it. Equal occurrence get of next. And this basically should give us
this match if we already saw next previously, right? So what do we have to do if we already saw? We have to say that the next number is the difference between the current turn and last scene. So
the next is
but we have, probably we have to change the names because we already have next, but we have to keep it. So this is the next.
New next.
Yes, okay. Number names are terrible. We will figure out them later. Let new next be the current turn minus last scene. Cool. Else, new next is 0. What is the rule? If we never saw it before, we will go in an else, right?
If we never saw it before, the new next is going to be 0, basically.
Okay, probably we have to define new next for the if and make it mutable. Yeah.
And I think by default we can make it 0 because it looks like a
without the let if you define that before.
Right. Otherwise it's gonna shadow. Next equal 0. Okay. And now regardless we need to assign.
We have to remember that we saw next in the current position.
So occurrence
turn
insert.
Python.
We need to do the next and this is gonna be current turn, and then we swap new next with next. So
now next is the new next. And now we see here with mutable references and everything else how it's going. Because obviously it's contained.
Yeah. So this needs to be a reference, I think.
Is already a reference. Do you have to put the star? No.
You put the star, yes, because it's already a reference. This one needs to be, so we are assigning Okay, this needs to be a reference.
And now he's complaining about one gazillion stuff.
Because I think again, okay, because again we have a usides reference and usides as a value.
Yeah, that's
so
maybe line
maybe
12 can't be just a usides. No.
Exactly, that's what I was thinking. And here we do reference. Now this one is up. This one I think needs to be as it is, and this one can just be this. Now why you are not up here?
It's never used. It's not true. It's never read.
Yeah.
No, it's read. In line 21 is read.
I guess it's figuring out that we always override it. Like the first time the value doesn't matter.
The first, yeah, it's true. How can you tell him? Well, if you don't assign anything, you just declare the variable. What is going to happen?
Yeah, generally, I don't do that. Let's see if it's possible. Yeah, it is.
Like in C.
Okay.
You have to declare the variable up there. Then
fair enough. I thought you were forced to add a value, a default value, but I think in this case it is smart enough to figure out.
Yeah, smart enough to figure out that if it is in an else, or one or the other is going to pass through. So.
Okay, so the last thing we need to return is next, right?
Yes.
And next, I think we declare this as U32. We can probably do usides.
Yes. It's breaking down.
And then we'll need to change the test because, do we?
No, because tutor.
Because we are straight comparing it, so it doesn't matter.
Yeah.
Sounds
so
good.
It's figuring out that we are comparing usides with usides. Literals.
So
we run this, is working or not?
Fingers crossed. 3, 2, 1, go. Ooh, very slow. This is worrying.
They are just shoot out.
Did we do like an infinite loop or something like that?
We did a numeric loop. No. Let me. No. Okay, no.
So what if we do cargo test from the terminal?
No, it's not an infinite loop. We have a starting value, an end value. How can it be infinite?
How do you open a new terminal?
On Linux is Control Shift back quote. Probably is Command Shift back quote on the Mac. No.
Option Shift back quote? No. There. Okay. It's Control Shift back quote.
Like in Linux.
Right. So if we do cargo test
of everything,
is it gonna do an endless loop? Okay, it did fail. So there was something weird in the previous terminal. And it's finding 0 and it's and it was expecting 2, 3, 2.
Okay, so something strange is happening.
Ooh, we have guests. Let me reply in the chat. Hello, Javier. Hello, Podge.
So
okay,
for the bug purpose, can you print next at every loop?
Yes, at the end or at the beginning? I guess at the end, right?
Try at the end. We know the first 6 numbers because they are the input, so we care about the numbers after the first.
So what we could do, and this needs to be a macro, we can say the turn and the number, right? So we can say turn and next.
And the next, yes. Let's see, what do we have?
And now I'm curious if we run the test from here, if now it's going to work. Yeah, now it's going to work. I don't know what happened earlier.
Do we also have outputs or okay?
We do. I don't think I'm going to be able to scroll at the very top.
No, but we
at the bottom, we want to see if it's off by 1 error, right? Yeah, it is.
It is off by 1 error, like we said before. Is not with the equal, it's just dot dot.
Okay, so we are running an additional turn, basically,
yeah.
which we should
because
run.
when we have 3-2 in our end, that is the turn 2020. We are playing the round 2020 and computing the round 2021. That is not the requested value. We want to compute the round 2020 and stop there. Because
fair enough, yeah.
On line 21, you set the value for the next round. And then you compute the round to 2021, but it's not what we want. So basically,
now let's run it again, and if that works, I will do what you
remove the print because
remove the print because we don't need it anymore.
Yeah.
And now if we run this guy, it works. Magic.
Off by one error, something new. Never seen
So
before.
what I want to do is to do something like a new test, which is what you suggested at the beginning, to run all the examples, basically.
Yes. We can do multiple assertion inside the test. Yes.
Yes, we can. So what we can do, I think we can even do an array. So let me copy all the things from here.
Basically,
from input, sorry, from readme.
I don't know if you have fixtures in Rust cargo tests.
Not that I'm aware, but what we can do is let I don't know, expectations equal.
In the end, is an hashmark between strings and numbers.
Exactly, and I think what we can do is do tuples of inputs.
Yeah. You can do a tuple or a map is an hashmark.
And the number that is expected.
Yes.
And we do that for every single case. Okay, almost. I wanted to be smart, but I was not.
A multi-cursor, if the length is different, is going to kill you.
I think I can do it. No.
Yeah.
I can't. Okay, I'm gonna do this.
Give up. There are 5 lines, Luciano, please.
Yes.
I understand that good developers are lazy, but there is a limit to it.
Right, okay, so this is something that I think is going to work. And now we can do for case in expectations, in case we can actually say input and output, I guess. In expectations, and here I think what we can do, did I misspell it?
Assert equal.
Oh, dot iter, I think, because it's an array and it's not iterable on its own. And now input is a reference of an str and output is a reference to i32. We could do this as usides, but it doesn't matter.
Let's try to assert it to see if he understands and changes the type.
Yes, so what we want to do is assert eq and give it part 1 of input. I think we need an asterisk here, and I don't know if it's going to be smart enough. Anyway,
is a double reference. Okay.
Output, I guess.
And now is a usize. You see that infer the right type. Basically.
Nice. Yeah, this is pretty powerful. I didn't expect this to work. I was expecting here to having to do something like as u32 or whatever.
Try to run them. Okay.
Yep, it's doing all of them. Okay, so our implementation is sane enough.
Now we have to look at the second part.
The second part, let's have a look. But I remember it was just simulating more numbers. So let's see.
So we can make a more general function and call it with a new parameter that is the number of iteration. Okay.
Okay, so let's see. Oh, and there are even more examples, so we can also add those to our tests.
Yeah, but that quantifies also the number of
iterations. Yeah. Okay, so that's saying there is a challenge, and it's to determine this. Like, what is it? 3 million?
30 million.
30 million.
30 million. Yeah.
Do you think we're gonna have memory issues, or I don't know? Our approach is gonna be slow, or
in the end, the 30 million numbers are with the U32 are 120 megabyte of memory. You have 120 megabyte of memory in that machine, I think. Even if we never match a single number that is always the same, that is impossible.
Yeah, it's still a small amount of memory, I would expect, right?
Even in worst case, is not a relevant amount of memory. And about speed, let's try.
I think the only issue might be that we reallocate the hash map multiple times, but at the same time, I wouldn't worry too much.
We enlarge the size of it. Oh yeah.
Yeah, I think an optimization we could do later is to figure out if there is like some amount of memory we can give it as a capacity to the hash map.
The worst case scenario of the capacity is the number of turn.
So 30 million, right?
Yeah, and the 2020 in the first example, because it's the worst case where you never go in the same number again. Like I said, it's impossible. But
exactly. So let's do a fan game, I guess, where we have. Do we just pass input as an str, I guess?
Yes.
And iterations as usize.
Iteration cards and it return a usize.
And basically we copy all of this as it is.
Yes.
But iterations is going to be rather here, right?
Yeah, the 2020 is now iterations.
And now this one is just going to return, what did we call it? Game, input, and 2020.
Done.
Now if we run the tests, this is still working, and this should still be working. Yes, it is. Nice. Okay, so now if we want to generalize the tests as well, we can do here 2020.
Well, if we call part one, you want to. Okay,
and we just call game. Okay. That's what I'm thinking. And this is going to be iterations.
No, you have to pass it in game, not there.
Oh, yes, sorry. Iterations here, and we remove it from here. I think we might need an asterisk, but I'm curious. Yeah, okay.
Okay. Or we could use take as parameter. Oh, well, that's not going.
Now, what I was thinking is that, like, to make it very easy, if we just create these ones, we can add them to our initial test here.
Yeah.
Right. So let's try again.
Multi-cursor magic.
Let's see if this time I can figure out a better approach. Okay, it's looking good.
Okay, this is aligned more. Now if you go end, okay.
Ooh, nice. And now it's going to be 30. 1, 2, 3, 1, 2, 3, right?
Okay, yeah. The comma in line 55 is good? Or?
Line 55. Oh, yeah, I think it doesn't matter. Actually, if you remove it and you save, I think it's going to add it again. Yeah.
Okay, so like Ingo.
Now, if we run this guy, I don't know if it's going to be fast enough, but let's try.
It started to be a little bit slower, and we ran it for 1 gazillion times now, 6 or 7.
Yeah, because
probably we can make a coffee.
Yeah, that makes me a little bit worried that maybe there is a smarter approach to this problem.
Well, we have to say that we have to compute it once, not what are 7 of them in that test.
Mm-hmm. But even if let's stop this guy, right?
Yeah.
And kill this one, even if we leave just one of them.
Yeah, okay, let's try with one.
Let's see. I think it's doing that terminal bug again. Come on.
Okay, it's not even starting. Can you kill it somehow?
Okay, I think now I killed it. Let's remove all the others.
Oh, but the others, we saw that they are very fast.
Yeah, they're very fast, just in case. Now run. It's building.
Yeah, your terminal is not.
Okay, my terminal is screwed. Yeah. So it was this. Let's do cargo test. And this should run everything, all the tests in our previous projects, including these ones.
Okay, this one is the size 15, so is the current.
Yeah.
It's taking its time. Strange. They are 30 million loops, but they are integers in the end. Well, there is the lookup in the. Okay, it passed.
Okay, it did finish. It took.
Yeah, it's not super fast, but it's a reasonable amount of time, I think. Everything running 28 seconds, so probably it will be 20 seconds alone, one loop over 30 millions turns.
So basically, if we want to solve this problem now, it's literally going to be just this and 30 million here.
Mm-hmm. And probably
actually, I think in Rust we can do this, which is pretty cool. Let's see if that works.
Let's see. No.
Does it?
Change the time.
Oh yeah, this one needs to be U-sides.
Okay, we can. And yeah, try to run just part 2. So it's one shot of that one. And
let's see what it does.
Yeah, probably will take 20 seconds or something more. That is still a reasonable amount of time, I mean. To be honest, to see an optimization, what could we do? Instead of having the hash map, we could start looking back in the array. 24 seconds. But probably this is slower because the hash map.
But that also means you need to keep the entire array, which we are not.
No, we are.
I mean, we are doing without duplicates.
Yeah, exactly.
With the hash map, basically.
Yes. And also the random the access to the hash map is faster than going backward in the vector to look for numbers.
Mm-hmm.
It's O1 against O(n). So from the point of view of being fast, if there is no mathematical trick, I mean, if there is no formula to get it in O1, and I don't think so, but we can figure
Yeah, my expectation is that probably there is some mathematical trick we could exploit here, but I cannot see it right now.
No, me neither. But again, 20 seconds is not an horrible time.
Okay, so I'm not going to run all these ones, otherwise our test suite is going to be super slow. So probably let's keep this one commented and let's leave all the others.
Yeah, the small ones pass in a reasonable amount of time. Yeah.
So let's say these ones will make the tests.
Do you want to try to pre-allocate the size of the hash map and see the capacity of the hash map and see?
Oh yeah.
In the game function, I think it is. No?
Let's see if we can do, like, if for instance with vectors, what we can do is with capacity.
Yeah,
that's the one. And now capacity, we want to put iterations, right?
Mm-hmm.
Let's see if this make it any faster, because maybe it's gonna be saving some allocations.
Go with
So
this. But
let's run this one first, just to see that it's still working. It is.
Yeah, but this is so fast that we
And
can...
now this one. It was what, 24 seconds before?
24, yeah. Yeah, but here we are saving the memory allocations that I hope the machine is doing fast.
Mm-hmm.
Also, we are never shrinking, we are just enlarging, so it's just allocating more and more memory. No, the same.
It didn't change, yeah.
No.
There might be some noise, but I mean, there is no obvious improvement.
Mm-hmm. Also, because capacity is the capacity of the keys.
Is it, or is
I
it
don't know.
both? That's a good thing to check. With the specified capacity, the HMAC will be able to hold at least capacity elements without reallocating. So it's probably both, like key values.
Okay. What can is a very simple loop. I mean, it's an if, an insert, and an assignment. I don't think there's a lot to shave here.
Mm-hmm. Yeah, the only thing I could think is there might be some mathematical trick. Maybe there is some way that the sequence keeps repeating after a certain number of iterations, maybe. And then you can kind of reduce the size of the problem that way.
If you find a repeating sequence, you have a period, then you just translate it. Yeah, probably. We could re-add the print that we had before at every loop and run the small one, the one with 2020 iteration, part one, basically, and look in the output if there is something repeating. We could try now.
Yeah, let's do that. One thing is that I think we need to run that in the terminal, otherwise. Oh, my terminal is broken anyway, so I don't know.
Yeah.
Okay, let me restart Visual Studio Code.
Yeah, let's try to restart.
Actually, I'm gonna do a commit first. Okay, so now I'm curious if we run the test now, if it's gonna work. Okay, and we can copy this command here. I'm gonna do this in a terminal because I think if we do it in the terminal, we have a little bit more history. Otherwise, we don't have enough scroll history. Yes, okay, so I'm gonna add the print statement. I will need to share also the other terminal. Let's add the print statement first. So we wanted to add it here, right? So yes. Print ln, and we want to do turn, comma, let's do this. And the other one is gonna be what?
The turn and the next.
Turn and next.
Okay. So.
And now if I share the other terminal, share, come on. Okay, let's make it a bit bigger. If we rerun this guy,
why didn't print anything you saved?
I did save, I think. Let me try to run it here again.
You need a cargo bill?
Oh, here it's working.
Cargo bill?
I think I might have removed some argument by mistake. I think there was something like no capture or something like that. Yes. Okay.
Okay.
Oof. Lots of stuff. Okay. So we are starting from turn 6.
Okay, I don't see any.
Yeah, there is no obvious repetition.
I don't see any pattern.
Also, 0 is reappearing like almost randomly. Like here, there is only one number. Here, there are like 3. Then
Yes,
one number again. Then
because the
3
zero is
numbers.
the zero is this number was never seen before. And when you
Mm-hmm.
put a zero, obviously the zero was there before somewhere, and so you have to fall back somehow. So there will be a lot of zero. Would be one of the most frequent number probably.
Yeah, often there are only 3 numbers, but it's not.
No, it's not a
It's
rule.
not. Yeah, it's not a recurring rule. Here there are 4, and then there is 2. So yeah, it's weird.
No, I think you can just run the simulation like it is. I don't.
Anyway, we could skip turns, no, right? Because otherwise you are missing what is the next number.
I can't imagine how skipping, and there is no evident loops. I mean, the numbers. There are a lot of new numbers. Every time there is a zero, it means that there is a new number. Every time there is a new number, it means that you are not in a loop.
Mm-hmm.
You are in a
Yeah,
loop
and
when
that new number will determine a new behavior because then, yeah, there is no consistency again because you'll need to figure out when that number is going to appear again.
yeah. And if you have a loop, you will stop seeing zeros. Go to the end. Let's see if the zero become less frequent about around the end. No, like they're still there. Yeah. No,
Yeah, 0 is still very frequent.
yeah, there is yeah. Zero, then a ramping up of numbers, more or less, because 991, for example, is not ramping up, is ramping down.
Mm-hmm.
991, then they ramp up to a big number, then back to zero, and then they start to ramp up again. But with not a repetitive length or repetitive numbers, no.
It is always fairly small, but I think this is just, I don't know, statistics, right?
Yeah, because every time there is a new number, for example, that segment in 1609 is longer than the others. Why? Because, yes.
Mm-hmm. Yeah, like this one as well. It's slightly longer than the others, but it's still what, 7 or 8 numbers?
Yeah, and also is not
7.
and also is not monotonic. Is
Mm-hmm.
not just going up, is going up and down. Yes. No, I don't see any pattern. If somebody see a pattern, open up a request and we can implement it. But like this, I don't see any pattern.
Okay, so I think we are coming up at about 1 hour. I don't think it makes sense to do a new exercise. I don't know
Yeah,
if there is any opportunity for
there is
other
any
stuff.
optimization that we can do? No, because we already put the code outside. There was not to fight with lifetimes or stuff like that.
Let me share again my editor and we can review the code. Yeah, also the other thing is that since we only have numbers, we are not, I mean, we are not using custom structs or anything that we could make it a little bit nicer.
In the end, there is an hash map of number to numbers. So, yes.
Mm-mm. Let's remove this one as well.
No, yeah, I think it's nice the syntax in line 32 with the underlines, like in Python 3, because it's
Mm-hmm.
easier to read.
Yeah, you can also do this in the latest ECMAScript. They also introduced this syntax.
So everybody liked it.
Mm-hmm. Okay, so what do we do? Do we leave it at this? Do we
I
do?
think, yes, I think for today we can call it a day. I was looking if there was something. I can't see anything. Yeah. Sorry, still just one stuff. Line 4 question.
Mm-hmm.
Basically, we are parsing and collecting. There is a way to have a cleaner syntax instead of writing the closure. No, map filter with just parse.
I think we had some other case where
Filter map, not
we were using filter map, but in that case we wanted to remove, I think, some values
But here
because we had like excess and we just wanted to skip them.
yes, here we want to do basically the same, but we are never going to skip anything because there are no strange strings in our code. Was the bug since the
Yes,
13, right? Go back to the 13 a moment in that filter map. Sorry. It was the 13, right? I think.
I think so. We had here this filter map with .ok, which is basically,
Okay.
yeah, I think filter map is converting. So basically, it's expecting an option, and when you do .ok, you are converting a result to an option. So if it's a positive result, so if you have a value, it's going to convert it to some value. If it's an error, it's going to convert it to none. So this way, it's basically filtering out everything that we are not able to parse.
Okay.
But in this other exercise, I don't think this is the case because we know it's always going to parse. Maybe rather than doing an wrap, we will be doing like an expect and say something like invalid input, something like that. But I mean, this is just to be more explicit in case of failure.
Okay, cool. Now, because every time that I see an unwrap, I think I'm doing something wrong.
Which is probably fair because you are just assuming that something that could potentially fail is never going to fail.
Yeah. And you know that for your inputs, you are never going to fail. It's true. But if we have an empty string as input, this code is going to crash, probably.
Yes. Yeah, fair enough. And the other thing is that unwrap, it's sometimes confusing because you can use it for both options and results. So you are making the assumption that something that can fail will never fail, or something that it's optional, it's always going to be there. So you need to be careful.
You're not covering all those cases that we don't have because we know that our inputs are valid inputs. But if you are in a real scenario, you have to be a little bit more defensive with your code. Probably writing a code test like I give you an empty input. What's happening?
I think this one is just gonna panic and give us invalid input if we try that. So here if we put, I don't know, X, and then we run the test, I think it will panic.
Not that one, because that one is their coded one, is not using the input.
Oh, yeah.
And also it's not working in your machine for some reason.
For some interesting reasons. Let's run this one. Okay, this one did work and panic straight away. Invalid input, and it was trying. Actually, this is a nice error. Parse int error, invalid digit. Where is getting this? I think it's getting this because the result here, it's an error type and it's showing us that value we'd expect.
And our message is nowhere. Invalid input.
There was our message, was invalid input, semicolon, and that error.
Sorry, I didn't saw it.
I can run it again because it was quite fast. It was invalid input and then a description, well, a representation of our result error.
Okay, cool. Yes, I think for today is all.
Okay, so let's see if we can do a raid.
But let's remember that we have a GitHub account. A GitHub account, a GitHub repository.
Okay, I'm gonna do all the ceremonies and then we'll do a raid.
Yeah.
So, as a reminder, thank you for joining us today. We do Advent of Code in Rust as an excuse to learn Rust. So if you're learning Rust as well, it might be an interesting exercise. If you already know Rust, you can help us to learn. So give us suggestions. All our code is available in this repository. We are also on YouTube. So if you are watching the live stream, you can check the previous videos on YouTube, link in the channel description. If you're watching this from YouTube, you can find the link for the Twitch channel in the video description on YouTube. So look at the current description and you will find all the links. And that's all for today. Thank you, everyone. I'm gonna try to do.
Trying to do a raid.
But it's only 2 people, so I think for today I'm gonna skip to do the raid.
Okay,
So,
we don't do a raid with 2 people.
Exactly.
Why not?
All right.
Bye. Bye.
Bye, everyone.